Datera is designed to be 100% programmable, from the infrastructure all the way up to the API, GUI, and ecosystem drivers. That means that with Datera, you'll be managing your storage in a declarative, programmatic way. You probably already understand why that's useful, but just to quickly touch on it, this is the gold standard for managing at large scales. You want predictable, consistent, repeatable, resilient configuration in an environment that's constantly changing. The ideal way to get there would be to express your configuration in well-tested code, that's the programmatic part, and have that code specify what you want, not how to do it, and then have your infrastructure figure it out for you. That's the declarative part. Doesn't that sound nice? Obviously, getting to that ideal is not straightforward. There's a lot of tools out there to help you with that, like Puppet and Chef, but the closer your environment is to actually supporting programmatic and declarative management directly, the easier your job is to drive it from your orchestration. So how specifically is Datera designed to support this kind of approach? Well, it's a pattern baked into every level of the product, starting with the way that we manage physical hardware resources. Datera runs on heterogeneous infrastructure with varied capabilities and resources, so we actually build an abstract model of these hardware resources that can then be detected, managed, and leveraged automatically by our software. This enables us to seamlessly manage the entire hardware lifecycle in a way that's transparent to the application layer. So adding new hardware, decommissioning old hardware, upgrading nodes to new software versions, etc., those are all zero-touch operations. In terms of the logical storage resources that you are managing as an end user, all such resources are modeled and managed through constructs that enable intent-based declarative configuration. First, policies to express the user's configuration intent and manage parameters such as data placement, QoS limits, and backup. And second, resource pools to allow automated rule-based segmentation of resources like IP addresses, storage endpoints, etc. So this enables an end user to simply express configuration intent, and now our control plane will figure out how to actively maintain and enforce that configuration across a dynamically changing environment. Finally, at a topmost level, we maintain this philosophy through to our REST API, which is the primary management interface of the product. The API is simple, consistent, and uniformly exposes all management functionality of the product. So the GUI, SDKs, drivers, and all third-party integrations are done through this same API that is available to you directly. So the software is easily and directly programmable and incredibly flexible, whatever your environment. Now let's see how this plays out in practice on a running Datera system. What you're looking at here is the API Explorer, which is a graphical interface for viewing API endpoints and executing them on a live system. It runs just like the web GUI on every system we ship. It lists out all the available API endpoints by category along with the parameters accepted, the structure of the response, etc., so you can quickly and easily understand the API and write scripts against it. Just as an example, I'm going to execute an API command here to set an offline hardware storage node back to an online state, so it comes back up and participates in servicing I/O. Note that as I fill out the fields in the visual form, the Explorer builds equivalent curl and Python commands that correspond exactly to what I'm doing. So I can literally copy and paste these code snippets and place them into scripts once I have the API called just the way I want it. This is also true from the GUI. As a quick example, let's change a little bit of configuration on a running instance of Datera storage. We're going to change the pool of IP addresses from which the storage draws its access IPs that initiators use to connect. Remember that resource pools such as these are a key part of our declarative management paradigm. Logical pools of resources that are declared and configured ahead of time, then running instances of storage point to a particular resource pool to draw from it. So first, we have to set this instance offline since we're changing the access configuration. Then we can go ahead and edit the storage instance, change the IP pool reference, and save it. Then let's set it back online. Notice that the IP addresses of the deployed iSCSI target have changed. Now let's jump to the list of user events, which contains a log of every action performed by an end user via every management interface of the product. And here we see the actions we just performed in reverse chronological order. First setting the instance offline, then updating the IP pool pointer, and then setting it online again. What I can do now is actually drill down and view the equivalent API call that was made to perform each request. So we're seeing rendered in code the action that was done through the GUI. This makes it really simple to translate your initial manual configuration via the UI into automated scripts against the API. So not only does our management plane model storage and infrastructure to you in a declarative intent-based paradigm, but we also make it really easy to automate and script on top of that interface through our API. And we're back to that gold standard of large-scale data center management, programmatic and declarative, brought to you by Datera.
Learn more about how Datera brings the software-defined revolution to enterprise storage at datera.io and contact Datera for a free consultation.